2212 Lab 1 report on the charged tapes lab. As an introduction to the lab, this lab was designed to use the concepts of charge, which is one of the properties of matter, using household objects to design experiments, making estimates, and simplifying assumptions, in order to calculate the amount of excess charge on an everyday object. The object in question for this lab is a piece of tape. The fundamentals of physics that are at play here are the Coulomb's law and the Newton's second law. Coulomb's law is force equals the electric constant, which is 9 times 10 to the positive 9th power, times the charge of object 1 times the charge of object 2 over the distance the objects are apart squared. And Newton's second law is force equals the mass of the object times the acceleration of the object. The fundamental proton charge is 1.6 times 10 to the negative 19th, which will be important later as we calculate the charge on the piece of tape. So the experimental setup here is I created 3 pieces of tape, lower piece, upper piece, which is also referred to as tape B, and the second upper piece, which is referred to as tape A later in the experiment. In order to get a charge on the piece of tape, I put the upper piece over the lower piece, and I pulled up the upper piece in order to get to an electric charge. This negatively charged the piece of tape, which was attracted to my hand, attracted to other neutral objects such as a book. However, it was repelled by another negatively charged object, which was a pin that I rubbed with a cloth. If you check over on the right image, this is my experimental setup for part 8, where I suspended a piece of tape, and then I would bring another piece of tape under it to suspend it using the electric force from tape A on tape B. I have the ruler there so that I can measure the distance without having to use multiple hands for different things at the same time. My results from these experiments, the length of tape was 0.02 meters long, the mass of the tape was 2 times 10 to the negative 5th kilograms. The distance between the tapes in part 8, which was the part with tape B suspended and tape A underneath, was 3.4 centimeters or 0.34 meters. And the tape is also negatively charged, as I described with the experiment with the pin earlier. The gravitational force on tape B is 1.962 times 10 to the negative 4th newtons. I figured this out using Newton's second law, which is force equals mass times acceleration. The acceleration due to gravity is 9.181 meters, and the mass of tape B is 0.00002 kilograms. And so multiplying those together, I got my gravitational force, which is going to be the same as the magnitude of the electric force on tape B, because the tape is not moving and is thus suspended by both the gravitational force pointing down and the magnitude of the electric force from tape A pointing up. Here's my glow script code. Tape B is represented by the red sphere, tape A is represented by the blue sphere. The green arrow is the gravitational force, the orange arrow is the electronic field from A onto B. If you look at my glow script code, a couple highlights are the charge find function, which takes in gravity and takes in 2 charged particles and returns the Q, which is the charge of those particles. And the end result charge was 7.08 times 10 to the negative 5th coulombs, which I say on this slide. The following assumptions were made to create the glow script model. Air resistance was ignored. The tape was treated as a point charge concentrated at the center. This allowed our calculations to be a lot simpler. And because the tape is so light, it also makes a lot of sense for this assumption to be made. And each tape had approximately the same amount of charge, which makes sense since we prepared both tapes using the same method, and they were both the same length. Lab report questions. What if the electrons had positive charge and the protons had negative charge? What would change about the observations you made with tapes and other charged objects? This would change nothing about the experiment 8, as like charges would still repel each other and the opposite charges would attract each other. The only change would be the slightest change in calculation due to the change in sign of the charged particles. And then, why was it important to handle the charged tapes as little as possible? It's important to handle the tapes as little as possible, as the charges can disperse from the tape to your hands if touched. A charged tape encounters another object. The 2 objects will reach electric equilibrium and lead to the tape becoming uncharged again. Thank you. This was my Lab 1 presentation.